Hey everyone, and welcome. Today, we are diving into a really core concept in Java, how to handle text that, needs to change. If you've ever tried to build a string inside a loop, you've probably noticed things can get a little slow. Well, we're about to find out exactly why that is, and then we're going to master the tools Java gives us to do it right, StringBuffer and StringBuilder. Let's jump. So let's kick things off with a big question. We modify strings all the time, right? You're building a user's full name, creating a long sentence from different parts. But why is something so simple sometimes a major performance killer in Java? That's the exact problem we're here to figure out and solve.
And here's our game plan for today. First, we're going to tackle what I call the immutable string problem. Then, we'll introduce StringBuffer as the hero of our story. We'll get into the weeds of how its capacity works, play around with its most useful methods, and then compare it to its close cousin, StringBuilder. We'll wrap it all up with a super simple guide on how to choose the right one. It's a journey from problem to solution.
All right, Section 1, the immutable string problem. This might sound a little weird, but we're about to see why, in the world of Java, your strings don't ever really change. And once you get this, everything else is going to click into place. Here it is, the single most important rule to remember. In Java, string objects are immutable. Now that's a bit of a fancy word, but all it means is that once a string object is created, its value, the actual letters inside it, can never ever be changed. Anytime you think you're changing a string, you're actually being tricked. Let's see what this looks like in memory. When you write a line of code, like string s equals hello, you create a variable called s. This variable doesn't hold the string itself, it just points to an object in your computer's memory that contains the value hello. Pretty straightforward, right?
But now, watch what happens when we try to add to it. When you run s equals s plus world, Java does not go to that original hello object and add world to it, nope. Instead, it creates a brand new string object that holds the combined value hello world. Then it breaks the pointer from s to the old object and points it to this new one. That original hello object, it's now abandoned, just floating in memory waiting to be cleaned up. Now imagine doing this hundreds of times in a loop. You'd be creating and abandoning hundreds of objects. That's where the inefficiency comes from.
So, if the problem is constantly creating new objects, then the solution has to be an object that we can change in one place. And that brings us to Section 2, StringBuffer. This is our mutable solution. Just think of it like a flexible, expandable container for your text. So what is it exactly? Well, a string buffer is a mutable, thread-safe sequence of characters. The most important word there is mutable. It means it's changeable. You can actually modify the contents of the object right where it is, without making a new one every time. The other key part is thread-safe, which is super important for apps with multiple things happening at once. We'll touch on that a bit more later.
And making one is really easy. You just say new StringBuilder, and you can give it a starting string if you want, like we're doing here with Naveen. What this gives us is one single, changeable object that we can now work with directly.
Okay, that brings us to Section 3, where we're going to uncover the secret sauce behind StringBuffer's efficiency, its capacity. I mean, how does it manage to be so flexible without constantly having to ask the computer for more memory? Well, to get this, you need to know two key terms. The first is length, which is exactly what you think it is. It's just the number of characters you've actually put in there. But the second one, capacity, is the cool part. Capacity is the total amount of storage space that's been pre-allocated in memory for that object. It's kind of like having a notebook with a bunch of extra blank pages at the end, just in case you need them. This table really breaks it down. If you create a totally empty string buffer, its length is 0. But look at that! Java automatically gives it a capacity of 16 characters. It's guessing you're probably going to add stuff to it. Now check out the second line. If we start it with the string Naveen, which has 5 characters, its capacity becomes 21. That's the 5 characters we used, plus another 16 characters of empty space. This is so smart, because it prevents the object from having to resize itself every single time you add one more letter. So, let's get practical. Section 4 is all about how you actually use this thing. What are the common methods you'll use to append, insert, and delete text inside a string buffer? These are going to be your best friends. .append just tacks stuff onto the end. .insert is for sticking text in at any specific spot you want. .deleteCharAt lets you pluck out a single character. And then, when you're all done with your changes, .toStringing converts it back into a normal, everyday string. Let's see .append in action. We start with our string buffer, holding Naveen. We call sb.append ready. And boom, The object now contains Naveen Reddy. But here's the magic, the most important part. No new object was created. We just modified the existing one, using some of that extra capacity we talked about. It's the same exact idea with insert at insert. Let's say we want to put Java at the very beginning. We just tell it to insert at index 0. And again, the object itself is changed in place, and everything else just gets shifted over. It's fast, it's flexible, and it's perfect for building strings on the fly. Okay, now we need to talk about a very common point of confusion. Section 5, StringBuffer versus StringBuilder. This is like a tale of two builders that look almost identical, but they have one tiny critical difference. And here is that critical difference. StringBuffer is thread safe. This means its methods are synchronized. You can think of it like having a lock on a door. Only one thread or one process can come in and make changes at a time. This is great for safety, but all that locking and unlocking has a small performance cost. StringBuilder, on the other hand, is not thread safe. It gets rid of all those locks, which makes it noticeably faster. Now, don't worry, you don't have to learn a whole new library of commands. The cool thing is that the methods are pretty much identical. They both have .append, .insert, and all the others. Seriously, if you know how to use one, you already know how to use the other. The only thing you have to remember is that difference in synchronization. And that leads us perfectly into our final section. How do you actually choose the right class? This is your quick and easy decision-making guide for any situation you'll find yourself in. It's really just a simple 3-step thought process. First, just ask yourself, is this string going to be modified at all? If the answer is no, just stick with the plain old string class. It's totally fine. But if you are going to modify it, you go to step 2. Do I need thread safety? Are multiple threads going to be trying to change this thing at the same time? If yes, then you absolutely have to use StringBuffer. But if you're modifying the string and you're in a simple single-threaded world, then you should always reach for StringBuilder to get that extra speed. So let's just recap the big takeaways. String is immutable, you can't change it. StringBuffer is mutable and safe for multi-threading. And StringBuilder is also mutable, but it's faster because it's not thread safe. At the end of the day, it all comes down to using the right tool for the job to make sure your code is as efficient as possible. And I'll leave you with one final question to think about. We know StringBuilder is faster, but in what kind of real-world app would that small performance boost actually be critical? Think about things like reading and combining huge text files, or maybe generating a massive JSON string to send over a network. That's where choosing StringBuilder can really, really make a difference. Thanks so much for joining me.